Okay, this is just trying to show how to load an overlay into MRIcroGL. So the default underlay is this MNI 152 2009 underscore 256. This is the standard MNI template brain, which is high resolution. So that should be loaded by default. But if it's not, you go to File. You can do Open Recent, and it should be listed under here. So here you see at the top, but if for something else was at the top, you could try to go down and find this one. And then, so that's fine, right? If you want to add an overlay, you just go up to File, Add Overlay, and then you need to find your .NI file, right? So here I went to the folder that contains all of my NISTAT analyses, and then I've got a folder here that, like, this is, for example, the SATCH data that we analyzed last week, right? There's this folder, double click on the folder, and then here I've got two NI files. There could be two or there could be three depending on your analysis, because so for example, this different one, it's got this one here, .NI, that's got sum. That just means the sum of all the subject's lesions. So you just see the overlap of the subject's lesions, how many subjects had lesions to each voxel. And then there's two other .NI files. One has got thresh in front of it. So both of these are statistical outputs from NISTAT. The thresholded one is got the multiple comparisons correction, whatever method you used, and whatever results survive the thresholding. So you'd only look at this because it's only, if you're only interested in thresholded results, you look at that. But I often am going to be looking at the unthresholded results here, particularly because, especially with preliminary analyses, you're likely not to have anything that survives the correction. So when you do that and you click open, you should see then this one popping up. And you can see here there's some voxels there that you can see. But if we were, if we were in a different slice, you might not always see those voxels show up. Like, so if I was there or something, then I might not necessarily see. But anyway, so yeah, the thing is that to be visible, so you should have this guy here, which is your underlay, and then this guy here, which is your overlay, right? If you uncheck that, it'll disappear. Check it again, it'll reappear, right? So that's just saying, do I show the overlay or not? Then here, this is your color scheme. So if I'm thresholding results and just looking at things that are, significant or not, then I just use one of these colors like red, green, or blue. And then I tend to use the same darkest and brightest color. So that thresholds it at this value. And then anything, basically, it'll be minimum 1.35596. It won't show anything that's lower than that. And then anything that's higher than that is going to be the same color. So all the voxels are going to show up as the same color, which is why they're all red here. But since we're looking at negative effects here, I want to threshold it at a negative value. So a z value of negative 1.645, that's equivalent to a p-value of p05 for a one-tailed t-test, negative 1.645. Right, so this will basically show anything that survives a thresholding of p05 uncorrected, right? There's a lot of options here, but I'll go through those in a second. But if you want to look at a range, right, because we know our z-values range even higher than this value, then I could type in, let's say, negative 2.5. Right, now you see that some of the voxels are brighter, some are darker, right? And that's basically just showing the range. Now, when you use these single colors, the range is, minimally, the contrast between the darker and brighter is less apparent, right? So it's nice to add a different kind of gradient. So you can use, like, they have like this one, this title hot, right? So it has basically a gradient from white to red. And so then therefore you can really see, the contrast between the voxels that are brighter and those that are darker. You can just play around with whatever ones you like. There's one that's called warm, which is similar, but I guess it's just in the yellow end of the spectrum. And then there's like red yellow, which can also be good. Yeah. So anyway, this should just allow you to see your voxel-wise results. The same thing will work for RY results. So if you file add overlay, let's say I want to look at the SAG ROI results, right? And then look at the uncorrected values. So here it's kind of weird because sometimes it shows all the voxels if they fall within the automatically selected range of values. But we can fix that easily. So first thing I'm going to do is this one is checked, right? Which means it's showing this older overlay and the newer one. So I'm going to uncheck that previous one so that one goes away. And then I click back on this one, right? It's green. That's kind of annoying. Let's do red, yellow. Okay, then we want to see basically the same threshold, right? So we want to go from negative 1.645, and I'm just going to go to negative 1.645. So anything that's survived this uncorrected threshold, right? So you see here that they've got the 1 ROI that was significant. And then sometimes it's hard for me to read these values. These, in theory, should be, the first three values are the coordinates. It should be X, Y, and Z coordinates. And then this last one, that one should be telling us the value of the T statistic, or the Z statistic there. So we can see a negative 2.798 is this value, right? Yeah. So hopefully that helps. I mean, you can sometimes be useful to do mask voxels with zero, hide voxels with zero intensity. That one, well, let's see, that's weird. I don't know why it does that. Why does it do that? I don't know. Sometimes it can be useful to avoid what we just saw. And then additive color blending is helpful for if you've got multiple overlays, you want to look at the overlap, but that's something we'll do in the future. But at any rate, hope that helps.